building React or any type of applications for that matter, will know that there's a million ways to do data validation, and none of them come without headaches. So we often find ourselves reinventing the wheel or struggling with errors we didn't expect, or we get frustrated with the API that just doesn't cooperate the way we had expected. So after today's session, I hope I will have inspired you a little bit to try out schema validation and see which ease it can bring to your daily workflow. So here's the schedule. We're polite people, so we'll start by introducing ourselves. Then we'll look at what schema validation is. Once we know that, we'll create a little form. We'll validate it with the schema. Then we'll want to send the data from that form to the API. So we'll see how we can use the same schema validation system to validate network requests. We'll go through everything we've talked about during the session, and if there's time, we'll have some Q&A. So, yeah, first things first, introductions. My name is Dries, also known as Designer. I'm 40 years old. I've been a front-end developer for about 19 years, and for the last 17 years, I've worked at Kronos. My current position is front-end lead at Kodara. And during my career, I've always combined front-end development with user experience and design. I'm also the co-organizer of JS Valley, together with David. I'm also an Aikido teacher. I'm a Shiatsu practitioner. I'm a bonsai enthusiast. I'm a father of 2 daughters. And I have a cat called Mango, which is not unimportant, as you'll see in a minute. But who are you? I like to know who I'm talking to. Does anybody here have have experience already with React? A little bit? Okay. And, oh, I have to go back. Yeah. Did anybody already have some experience with schema validation? A little bit less, okay. And then there's also always one question I like to ask. I'm always hoping there's somebody going to say yes. Are there any martial artists in the room? Yes? Okay, great. Usually I have to say nobody's perfect, but at least a few of them. Okay, good. So, what is schema validation? According to someone on the internet, schema validation is the process of validating the structure and the content of data against a predefined schema. Okay, so what's a schema? Someone else on the internet told me that a schema is a set of rules that defines how a data set should be structured. Cool. So let's look at an example. Here I've created a simple schema to define a cat. Our cat has a name with a minimum amount of characters of 1 and maximum 50, because, I mean, more than 50 would just be weird, right? Our cat has an age, which preferably is non-negative. It has a gender, which is usually male or female. It has a date of birth. We can optionally add a breed. And if your cat has a chip, you can also add the information. The schema was created with Zod. And Zod allows us to, I have this thing, right? Yeah. This, does that work? Yeah. So this Z here stands for Zod. It allows us to infer the type from the schema that we've created. So we have that Typescript type cat data, which refers to something like this. Our name is a string, our age is a number, a gender becomes a tuple of male or female. It has a date of birth, which is a date, and it has 2 optional parameters, which is the breed and the chip info. Okay. So who is this Zod guy anyway? Turns out it's not a guy, it's a library. It's a very cool library, TypeScript first library, which allows us to declare schemas and validate data against them. It's quite tiny, it's only 8 kilobytes, and it's designed to be very developer friendly. It uses a chainable interface, which in a few slides later we'll see comes in very handy. And it's immutable, which means that every method on that chain that we call returns a new instance of the created schema. It also has zero dependencies, which is cool. If you want more information, you can visit zod.dev. Okay, so let's create a schema. We'll make a schema to add some cats to a database. Here we have a simple React component, which renders a form with two inputs. We'll keep it simple for the presentation. It renders an input for name and for age. It has a submit button, which if we press, sends that data to a submit handler. Nothing fancy, just a simple form. So let's create a schema for it. We create an add cats form schema, which holds the two IDs of the inputs we have in our form. The name, which has a minimum amount of characters of 1, which means it's required, and an age, which is an integer, and it should not be negative. We again infer the type from that schema, and we can use that type later on when building that form. Now, before continuing to the form, let's talk a little bit about the library called React Hook Form, because we're going to use it in the example. Does anybody know React Hook Form? Has anybody worked with it? Yeah. Okay. I think you should if you're doing React, because it really helps you solve a lot of issues with the forms. It's a library created by Bill. The guy's name is Bill. I don't know. It's the only thing I could find. In 2019, it's built for modern React. And it supports lots of schema validators, because there's not only Zod, there's several. There's Joy and Yup and some other ones. React Hook Form supports React Web and React Native, which is cool. Way to go, Bill. You can find information on reacthookform.com. So back to our form. So we see we still have the same form, and we added a little hook called useForm, and it's a generic hook. That means we can give it the type we've inferred from our schema. That will tell that form that it's a form that will handle the data of type cat form data. The hook returns us two methods. One is called register and one is called handle submit. The register function will be used on the inputs to register that input in the form state, which means that if we submit the form, it will know that if we type something in the input, it will store it in the form state, and then when we submit it, it can handle it well. The handle submit function is wrapped around our submit, which basically catches the submit action of the form and allows you to do stuff with it. And the stuff we're going to do is we're going to validate it. So React Hook Form comes with a parameter called resolver, and we can add a function Zod resolver to it and pass our previously defined schema to it. So what that does is when we press submit on our form, the data of the registered inputs will go through the handle submit function. But before passing it on to our submit handler, it will first go through the Zod resolver. It will validate that that data against the schema that we've provided. And if that fails, it will stop the submission handling, and it will register errors in the form state for each of the inputs that we have in our form. We can then use those errors to display error messages for our users. But for the moment, we didn't really specify what we want to give as a feedback to our users, because in our form, we've added a name and an age, and we validate specific requirements. But if those fail, React Hook Form will just guess, and for example, for the name, it will say required, and for the age, it will say something like invalid, which is a bit, it doesn't say so much. Now, here's where the chaining comes in very handy, because if we look at age, we have an int. It should be an int, and it should also be non-negative. The chaining allows us for each of those steps to define specific error messages for that validation. So if our input, if we, for example, would input a floating point, the validation will fail on the int, and we can give a specific message there. If we give it a non-negative integer, it will fail on the second one, and we can give another piece of feedback to the user. We could also send this through a translation service, and we're good to go. Okay, great. So now that our form's validated correctly, it's time to send that data to the server. So let's look at how to use the same system to validate network requests. But why would you want to validate a network request? Because at runtime, we can simply not assume that we know the content of that data. Our API might have changed. The data might have become corrupt. We just simply don't know. So what we can do is we can infer the type from the schema that we've created. We can then validate the response against that schema. And if that validation succeeds, we can safely assert that the response is of the correct format, and we can go further. So how does that work in our form? First, we'll create a schema to validate the request body. Ooh, already. Okay, so I have to talk a little bit faster. So we have our request schema, the same, the name and the age. We'll infer the type from it. And in our submit handler, before sending it to the request, we'll first validate the data that our form has submitted to it, and we'll parse it through the schema. If that parse function fails, it will throw an error which we can catch in the try-catch block. Good. So what about updating a cat? We only want to update the age of the cat. My cat will be 1 year old next week, so I want to update its age, but her name will still be Mango. So I only want to do a partial update. We have functions for that. It's a method provided by Zod. So what about the response? Typically, our API will respond with the cat that we've created, but it will have added a unique ID to it and a created at. So if we compare that to the request schema, we'll see that there's some similarities. The name and the age are exactly the same. So if the API would change, for example, allowing floating points, then we would have to change the both schemas. We can solve that by taking the original cat API request schema and merging 2 extra options into it. So we're good to go again. So how to handle the response? We've sent our data to the API. We'll check if our response is okay, and then we'll take the JSON from that response, run that JSON data through the parse function of our response schema, and again, it will fail if it's, it will throw an error if it fails. If it doesn't, we can assume it's of the correct schema, and we can add it to the React state. So here's an example on how to use a schema if, for example, we want to load a list of all of the cats in the database. We can just use the arrow function and pass the same schema to it, and done. Okay, so let's test our code. Here we have a simple playwright test, which gets all the cats from the server. It expects that the response will be okay. We get the JSON, and then we run that JSON through the parse function of our schema, and we expect it not to throw an error. Cool. But there's more. Let's have a look at how we can use the same schema validation in React, in Next.js middleware, for example, to automate the process. So there's 2 functions on a schema. There's more than 2 methods on a schema, but the 2 ones we're going to talk about are parse and save parse. So the parse function, as we've seen, it throws an error if the validation fails. The save parse function will not fail, but it will return a tuple type, which you can see here. It will contain a property success. If the validation failed, it will be false. If it succeeds, it will be true, and the data will be added to the object. So using the first option, we have a simple API handler middleware. We'll send the request body through the parse function of our schema. If it fails, it'll throw an error, and in the catch statement, we can return a 400 saying what went wrong. The same we can do with the safe parse function, same system, but there we will check on the success parameter. If the success parameter is false, again, we can send a 400. If not, we can go on. TypeScript will be happy, and everything works. So where to go from here? We've really just scratched the surface of the capabilities of Zod. Because here, for example, you see all of the methods and functions we can use. There's very specific functions to validate IP addresses. There's async properties. There's a whole bunch of things. And the system of Zod tries to mimic TypeScript as closely as possible. But for some validations, we want to go a little bit more custom. So we can use refine functions to take a schema, refine it with our own logic, and then pass it on. There's also several tools available in the Zod ecosystem. It's a growing list. So there's several APIs available, TRPC, Zodios, several others. There's form integrations for, as we saw, React Hook Form, but also Formic. There's tools for Remix, Svelte, Vue. I think you were doing Vue. Yeah. There's converters, both from Zod to X and X to Zod. There's a bunch of utilities to be found, and there's also very interesting tools to automatically create mock data based on your schemas. So, to conclude today's session, what have we covered? We've seen schema validation using Zod. We've seen how it integrates very well with React Hook Form. We've seen how we can leverage TypeScript's capabilities to infer the types from the schemas. We can merge schemas and create partials whenever necessary. We looked at how we can use the same system to validate network requests, both the request part and the response part. We used our schemas in playwright tests. And we've protected the Next.js API with Zod. But there's so much more. So I hope you're a little bit inspired, because as you can see through the session, you can use the same validation system, the same schemas throughout the whole workflow of your application. So have fun, try it out. There's information to be found on, the purple is not so readable, but zod.dev for Zod, and reacthookform.com. You can use any form system you want, or you can use another schema validator as well, but these are my personal preferences. And my name is Dries. If you like, you can contact me. My email address is dries@kodana.be, and I'll be happy to answer any questions you might have. Or now, if there's any questions. Yes? I have to throw the box, yeah.
Hello? Okay.
Yeah.
So you mentioned there is an integration for Vue. Is that only Vue 3, or does Vue 2 work as well?
I haven't tested that one. I've never done Vue myself. I know it's available for both Svelte and Vue, and I'm assuming it's for Vue 3, but Vue 2 I don't know exactly. But actually, Zod actually works with the vanilla JavaScript as well. You don't really need TypeScript even. So I'm pretty sure you can make it work. Yeah.
Okay, thank you.
Yeah. Mm-hmm.
Did you ever try to make it the other way around? So you write your types first and then have some tooling to generate the Zod schema from the types?
Yes. For example, if you work with projects, we're mainly at Kodama, we work with projects that have a PHP background, backend, Laravel or Symfony. So the API will specify open API specs. And then there's tools like Orval, for example, to generate the front-end code to communicate with that backend, and you can use, for example, Zodios or Orval as well has possibilities to generate those types based on the OpenAPI specs. Yeah. No more questions? Okay. Then I think we can conclude today's session. Thank you.